So our learning target for today is I can compare fractions greater than 1 by creating common numerators and denominators. So today we're going to be using our skills for comparing fractions, the tape diagram, and multiplication, but we're going to use it with mixed numbers and improper fractions. So to start, we're going to look at these fractions. We have 3 3/8, and we're going to compare 3 3/8 to 3 3/4. Our first step is to make sure that both of these fractions are in the same set. So they're both either mixed numbers or they're both improper fractions. I'm seeing they're both mixed numbers, so my first step is done. My second step is to look at the whole number. I see that here my whole number is 3, and here my whole number is 3. That means that our whole numbers are the same, so we can look at the fractions. If my whole number here was a 4, I know that this mixed number is larger. If it was a 2, then this mixed number would be larger. But because our whole numbers are the same, our job is to next look at our fractions. So we have two strategies. I see 3/8 and I see 3/4. My strategies are either to draw a tape diagram for 3/8 and then 3/4, or I can use multiplication. I'm going to start by trying the tape diagram. Now, we have to remember when we draw our tape diagrams that they have to be the same size, same width, same length, all of that fun stuff. We have to make sure that they're pretty much the same size so that we're getting a good idea of which one is larger. If I drew one tape diagram larger, it wouldn't be an accurate showing. So I'm going to start by drawing 3/8 here. I'm going to partition this first tape diagram into 8s. I'm going to start by splitting it in half, and then I know that each of these halves have to be 4, so 1, 2, 3, 4, 5, 6, 7, 8, and I need to shade in 3 of these 8s. So I've shaded in my first tape diagram. I have 3/8 shaded in. And now I'm going to do the same with my second tape diagram. I need to have 4 equal parts, so I'm partitioning as evenly as possible, shading in 3 of those 4. And I can quickly see that there is much more shaded in for 3/4 than there is for 3/8, meaning that 3 3/4 is larger, or 3 3/8 is smaller than 3 3/4. So that's the first strategy we can use. We can use these tape diagrams. And remember, we're not drawing the whole. That would just take more time. We're just drawing our fractions to compare if our whole numbers are the exact same. So we have our tape diagram strategy. We also have our multiplication strategy. Again, our whole numbers are the same, so we can just do the multiplication for our fractions. So I can say, okay, I'm going to compare 3/8 with 3/4. And if I'm going to compare 3/8 and 3/4, I need to make sure my denominator is the same. So I'm going to look for the connection I see. So I can either multiply this whole fraction by 8 and this whole fraction by 4, or I can see that 4 goes into 8 evenly. So I don't have to do that much work. I can just multiply this one side, this one fraction. I'm going to multiply 4 and 2 to make 8. And I know if I multiply my denominator by 2, I need to multiply my numerator by 2, and I know that 3 multiplied by 2 is 6, and so that makes 6/8. And now that my units are the same, I go with the larger numerator, which is 6/8. It's larger than 3/4. And we can see that that is showing us the same thinking. 3/8 is smaller than 6/8, so 3 3/8 is smaller than 3 3/4. So there's two different strategies we can use. Now we could have also, instead of multiplying by 2, we could have multiplied this side by 4, this side by 8, but we had a common factor in our denominator. So two strategies we can use. We're going to do one more together or in this video, and then we're going to try 2 on our own. So you might see 2 mixed numbers like we just had, or on the worksheet you might see it written where you have one mixed number like 4 3/4, and they may ask you to compare an improper fraction. like 23 fifths. So now our job, we have one extra step. So we have 4 3/4 and we have 23 fifths. So before we can compare these two, we need to make sure that both of our numbers are mixed. And we practiced this yesterday, right? We were in the last 2 days, we're turning improper fractions into mixed numbers and mixed numbers into improper fractions. We're really going to practice just turning that improper fraction into a mixed number. So here, I can draw my tape diagram. I know that 5, if I skip count 5 fifths, we need to make sure our unit stays the same. 5 fifths, so we have 5, 10, 15, 20, 25. 25 would be too large, so I have to stop at 20 fifths. So that's going to be the first part of my number bond, 20 fifths. And now I need to see what 20 fifths plus what will make 23 fifths. Again, my denominator always stays the same. Well, I know 20 plus 3 makes 23 fifths. 20 plus 3 makes 23. My denominator stays the same. So now I can change this. I know 5 goes into 24 times, and that means I have 3 fifths remaining. So now, instead of comparing 4 3/4 with 23 fifths, I'm going to compare 4 3/4 with 3 fifths. So I can compare these two mixed numbers now. So by changing my improper fraction into a mixed number, it makes my job easier. Now I can compare I did that first step. Now I can look at my whole numbers. They're both 4. They're the same. So now I can really focus in on those fractions. 3/4 or 3 fifths. Which one's bigger? Well, again, I have those two choices. I can draw a tape diagram, or I can use my factors and multiplication skills. So I can draw 2 tape diagrams. They have to be the same size. Shading in 3/4 to begin with, so shading in 3 of my 4, or shading in 3 of my 5. And I can see 3/4 is a little bit larger than 3 fifths, which means 4 3/4 is larger than 4 3 fifths. Now I can check my work by multiplying 3/4 and 3 fifths by the denominators to make them a common denominator. So I can do 4 multiplied by 5, which is 20, which means I have to do 3 multiplied by 5, which is 15. And then on the opposite side, I need to multiply 5 by 4, because it's the opposite denominator, which will also be 20. And now my units are the exact same. I have my units of 20. I can multiply, if I multiplied 5 by 4, I must multiply 3 by 4. 3 multiplied by 4 is 12. And now which is larger, 15 twentieths or 12 twentieths? Well, 15 is a larger number than 12. So 15 twentieths or 3/4 must be larger than 12 twentieths or 3 fifths, which means we were correct. 4 3/4 is larger than 4 3 fifths. You're going to try 2 problems on the PowerPoint, and then you can go to the worksheet. Make sure to check in with a friend before you go to the worksheet.